Okay, I think we'll start. I think we will have one or two more, not many more. Okay. It's very nice to be back in Kiev. This is my third year or fourth year in a row, I can't remember, of coming to the city. I love it here. Today's session is continuously delivering infrastructure to the cloud. It's very difficult for me to say at the minute. My name is Paul Stack. I'm pretty much everywhere on the internet as Stack72, so GitHub, Twitter, anything. If you have any questions or comments, send me messages or tweet me or email me, do whatever, right? I'm happy to go through as much of this as anyone wants and as much as people actually care about. I work for a company called Joyent. Joyent are a small cloud, and it's a company that was recently bought by Samsung. So Samsung, everyone knows who Samsung are, and so we're starting to grow and grow and grow in the cloud space. Up until very recently, I worked at a company called HashiCorp, which I'm sure some people in here know who HashiCorp are. I was one of the engineers on Terraform, so a lot of my demos today will feature Terraform. I apologize because I know there's a Terraform talk tomorrow, but this is not much about the tool. This is more about the process of using it. I've got a few slides to go through, and then we're just going to go look straight at code, okay? I've been in IT now for over 15 years, and one thing I've learned throughout the years is long-running servers suck. They really do. They're absolutely terrible. Okay, I worked at a company very early in my career that was deploying Windows 2003 servers, and those servers were in production for maybe 15 years. Okay, people were manually patching them. They were remote desktoping into those Windows boxes and making changes in each one individually. When you have a cluster of 20 servers, that's not too bad. When you have a cluster of 1,000 servers, that's unmanageable. Okay, so every server was individual, every server was unique. And we got into the situation many times that our development environment was completely different to our production environment. Anybody in here faced the same thing before? Yes, I see a lot of people nodding. Okay, it's very common in IT that that's the case. I'm a developer. I take that back. I used to be a developer. I'm much more of an infrastructure guy now. I like building infrastructure and playing around in the cloud much more than I like writing application code, because I was never very good at writing application code. But there was a lot of different processes in infrastructure management. And we went from long-running servers, which were like snowflakes, and then we went into configuration management. I'm not saying don't use configuration management. That's not the point of the talk. Don't use configuration management. No, I'm joking. I love Puppet. I love Chef. I love Ansible. Okay, I've used all of those tools, and they're all very useful, and they have a great piece in what we do every day. But in 2013, I got introduced to a different way of thinking. Okay, a blog post by Chad Fowler, who was the CTO of Six Wunderkindle. It made the to-do list called Wunderlist, okay, based out of Germany. And he wrote a blog post saying, trash your servers and burn your code in mutable infrastructure and disposable components. Now, in this article, Chad actually describes a completely new way of doing things, okay? He actually describes what's called as a mutable infrastructure. Definition of a mutable infrastructure is you make that deployment once and you never change that infrastructure. Okay. If you need to redeploy or make a change, you deploy new infrastructure in its place. The cloud makes this very easy, okay, because commoditization of compute instances in the cloud is very cheap. So, for example, Amazon now charge per second, okay, per second billing. You can have an application that runs for 5, 6, maybe 7 minutes and still only have to pay for that in seconds, rather than what it used to be was you spun it up once and you had to pay for the full hour. Okay. The introduction of serverless has made it even more so. Like in Amazon, for example, you're charged maybe 1.5 cents for every million invocations of an AWS Lambda. Okay. So the way we think about infrastructure is now completely different. Completely different. Hands up who is in the cloud. So a few. Hands up who are in virtualization in their local data centers. A few of those as well. Anyone still running physical servers? I would love to hug all of you. Physical servers are near and dear to my heart, okay? Like, I used to tinker with them for many, many, many years. Please tell me, is there somebody with Windows physical servers? I owe you a beer. I'm buying you a beer later. I can promise you. I promise. Do you know what? We're done. We'll just go and have a beer now. But seriously, life is tough when you're on physical servers, okay? Because the way that you do things is very much specific to the capacity that you have in your infrastructure or in your data center. So what I mean by that is, Immutable infrastructure is a little bit tougher for those people who have physical instances, okay? Because you can't just deploy a new physical server very quickly, okay? Because it usually goes through the operations team. It goes into the networking team. It goes to the security team. And then maybe it goes to the QA team to make sure that it's fit for purpose. Okay, so it takes a longer process. In the cloud, you click a button or you use command line tools and they spin up within minutes. So life is a little bit easier for those. So we always have to think more about that. Now, any developers, any functional programmers in here? Good. So functional programmers decided that this wasn't actually a mutable infrastructure, because for this to be a mutable infrastructure, you would have to have a read-only file system. Okay, who the hell has a read-only file system? Like, honestly. Also, you would have to stop people SSHing or RDPing into boxes, because developers are greedy and like to break things. Sorry, touch things. So what we decided, well, not we, a conversation on Twitter happened, and it was decided that maybe disposable infrastructure was a better terminology for it. So infrastructure that was created and has a lifespan, and when that lifespan has exceeded, is killed. Okay? Because we all know in software we're very good at killing off old things, right? There's a lot of projects on the internet right now that are still alive that probably shouldn't. I'm not going to give you any mentions because this video is recorded. If it wasn't recorded, I could rant. So the way we have to think about our systems is we have to think of them as cattle, not pets. When a farmer has cattle, he doesn't give each member of the herd an individual name. He doesn't go, oh, here's such and such, or there. They have a number. They usually have like an ear tag or a stamp on their back with a number. Okay. Unfortunately, cattle die. And the farmer will go and get a new member of the cattle in order to replace the last one. A little bit more difficult when you have pets. Okay, when your cat dies at home, you cry a little, you sulk a little, you kind of question if you're going to get another one. So you have to think of it that time. Now, here's where we intersect with the software delivery world. Okay, for years, software delivery has gone into continuous integration and continuous delivery. Okay, but those nice operations people have sort of been like kept away from all of this. Okay, they usually have a little office of their own. We feed them pizza when we want them to do something, and we give them like intravenous coffee when they have to wake up all night long and deal with bugs. So over the past year, I've been doing a lot of work about trying to work out how we can start to like bring these two, because of the rise of DevOps. Okay, I'm trying to work out like, is there interesting ways of being able to demo what we can do in order to bring these together? And I found that there was. Okay, so continuous delivery, for those that don't know, is a set of practices and principles aimed at building, testing, and releasing software faster and more frequently. Now, I know that says software. You cannot run software without infrastructure. Your pretty code is completely wasted until it's actually in production. You could have taken weeks to do it, but if it's nowhere, it's not making money. So you need infrastructure. You need operations people. As much as they sometimes are very angry people, we do need them. There's principles, you can go and have a read of them. I'm not going to go through them. But the most important thing is that there are 4 practices. Okay, and the same thing applies. These are the actual real 4 practices as denoted like on the internet everywhere that you go. Okay, firstly, you build your binaries once. Look, we can relate that to what I just said about infrastructure. Build your infrastructure once. These slides are available, I promise you, okay? Secondly, use the same mechanism to deploy to every environment. Oh, look. At that point, we're actually thinking about the same production environment as the same development environment. Look, it crosses over perfectly. Number 3, smoke test your deployment. If you're not smoke testing when you deploy something being a question mark, schema change, or code change, or an infrastructure change, you've probably got bigger problems. Okay, something's going to go happen, something's going to go missing. And lastly, and most importantly, if anything fails, we stop immediately and we fix it. Okay, this is the most important principle of all of them. Because if you have something wrong in your networking stack, or in your storage layer, or in your database layer, you've got to stop. You can't just continue pushing code out because you don't know if the code that you're pushing out will work when your actual layers that are fixed will actually work. Anyone read the book, Continuous Delivery? Anyone who hasn't, I urge you to take that book and read it. Okay, this was written in 2010. Yeah, 2010 by Jez Humble and Dave Farley. Okay, so this is not a new concept. Okay, continuous delivery has been going around since like the 60s. Okay, I may look old, I may look like I'm 65, but I'm actually not. But I promise you, it's been around for a long, long, long time. Okay, and because it's been around for a long time, it's tried and practiced, and it actually always does work. Okay, now you may not be able to just go and take this book and checklist everything off and go logging, monitoring, alerting, CI. You may not be able to do all of those things within your organization, but the point of the book is about continuous improvement. You can take small segments of the book and you can actually apply those small principles within your organization. Now, let's get rid of all the boring stuff and let's actually go and look at some code and how we do this. Okay, so I'm going to use two tools today. Both, as I said, are by HashiCorp. Okay, one is Terraform and one is Packer. I worked on, as I said earlier, I worked on the Terraform team up until July, and even though I've left the company, I still actively push code back. So I opened a pull request just this morning, and I also push code back to Packer as well. For me, my life as an infrastructure person would be so much more boring and repetitive and really rubbish because I would have to write all my own scripts without these two tools. In a nutshell, for those who haven't, it's like a 2-minute introduction to Terraform. Okay, Terraform has a number of providers. When we say a provider, we mean something like AWS, Azure, Google Cloud, Triton, which is my cloud and Joint, DN Simple, DNS Made Easy. It even has things like MySQL providers, which it will go and connect to your MySQL database, provision users, provision like different pieces of your environment. Inside each provider, you have a number of resources. Now, a resource is like something that's tangible to your infrastructure. Okay, like a VPC, an instance, a subnet, an elastic IP, an S3 bucket, etc., etc. Okay, something that's very tangible to how everything links together in your organization. And Terraform's based on graph theory. Okay, so I'm not professing to be a mathematician. Graph theory in 2 or 3 sentences is nodes and edges. Exactly. 3 words, nodes and edges. Okay, nodes in this case are like instances or subnets or VPCs, and the edges are the relationships between them. Okay, so for example, this AWS instance sits in this subnet. This subnet sits in this VPC, and so on and so forth. Now, because of that, we know the order in which that they have to be created. So Terraform uses a directed acyclic graph. Okay, that's all the mathematics done. Okay? There's a really good talk in the bottom of my slides on this about that infrastructure as code based on graph theory by someone who I used to work with at HashiCorp called Paul Hinsey. I'll let this man take a picture. Okay, so we're just going to go into a demo. Appearance. Let's just change the color scheme to make it a little easier to read. Very good. Okay, so before I, just this morning, I created an AMI. Okay, now here's the controversial part of my talk. I use AMIs everywhere. I love images. I love them because they're pre-built, they can be pre-tested, I can validate that they work, and it's repeatable. Okay, so I can deploy. I use my AMIs in much the same way as people use Docker containers. I bake my applications into my AMIs in advance. Okay, I know some people don't like that. This is not me telling you that this is the way you should do it. Okay, you can do much of everything that I'm showing you today with Docker, okay, or Kubernetes, or all of these different scheduling tools. Okay, this is just about thinking your process through. Nothing else. So I baked an AMI, and my AMI always has tags. Okay, so I use something like component, conference, OS, version. So web application, XP days, Ubuntu 16.04, which is the operating system, and version 1.0.0. That means that that application AMI is 1.0.0, and I can deploy that very easily. So I'm going to go and do that in the background. I just ran Terraform plan a second ago, just before everyone sat down, and it tells me it's going to go and do a lot of things, and we're just going to go and apply that in the background. Now the interesting thing here is inside my Terraform script. The Terraform script is not the interesting point. Okay, inside my Terraform script, I have this code block, right? Data, AWS AMI, application instance AMI. Okay. At this point, I'm saying go off and get me the AMI ID that meets tag conference being XP days and tag version being 1.0.0. Okay. I can use Terraform to deploy 1.0.0 of my application. If I really want to, I can change that to 1.0.1 or 2.0 or so on and so forth. Okay. This is only a variable. Of course, we'll talk about how we push that in via CI in a little bit. But the main thing is that I'm actually deploying 1.0 of my application using Terraform, and we can go back to AWS Cloud, and we can see this is the instances, and right now we have 3 instances that are currently spinning up, and it's rolling out right now. Anybody have any questions so far? Everybody awake? You okay? So this is like as basic as possible. Okay, this is really as basic as possible. Now at this point, what I'm going to tell you is, as I said, this is a variable. So I can do var dot AMI version. Okay, and inside my demo code, in my inputs or my variables, I can actually say variable. What, I can't remember what I called it. I'm really sorry. And I can say default equals 1.0.0, 1.0.0. Now, because of the way Terraform works, you can actually pass that in as an environment variable, or you can pass that in any way possible. I can actually turn around and say export tf AMI version equals 1.0.1. And that will overwrite the variable locally. Now you can see is that if you don't pass in an application, or if you don't pass in a command line variable, it will try and deploy 1.0.0 of the application. So our CI tool, when we want to rev it, can turn around and go, oh, there's a new version of the AMI available. Let's roll that out, and let's push that out that way. So we'll come back to that in a second. Come on, AWS. So I'm getting like 5 kilobytes a second. Can everyone like stop on the internet a second? Here we go. Okay. So at this point, we actually have an application, load balancer up, and this is the most sophisticated application you will ever see, I promise. Welcome. Now you can see why an infrastructure developer and no longer an application developer. But it's just to show you right now that we have 3 versions, 3 instances of an AWS server. And we actually have version 1.0.0 of the application running, okay? And I can refresh it, and it'll never change from 1.0.0. So we're going to go and we're going to have a look at what we're doing in Packer. So my Packer script is very simple, okay? Very, very, very simple. This is as nasty as it gets because it's written in JSON. I apologize for that. I had no choice in that decision, but it's useful, it works, and you can actually validate it and lint it as expected. We pass in a source AMI, we pass in a region, and we pass in a version. Okay? Now, all it does is it just copies some Nginx files across and just rolls them out. So I'm just going to bump the Nginx file. Really, I am awesome as a developer. And it just has an Nginx configuration. Now, why is Packer so special for me? I'm just going to run this in the background. I can run the command make validate, and it's going to validate that my template works. And I can make AMI, and that's going to happen in the background. Oh, no, 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 no. No, I'm going to pretend that I've pushed that in via CI. So why is Packer very special for me? I can actually use spec files, okay? I can actually test all of my Packer configuration. There's a tool on the internet called ServerSpec. Okay, it's at serverspec.org, and it will actually allow you to test how your application server looks. So, for example, I have just very basic specs just to show you. So when I run my Packer script, and Packer brings up the box and it successfully does all the configuration of the box, then at the end of the Packer script, it will run specific tests. So the first test it says is that Nginx should be installed. Nginx should be enabled and running. Nginx should have port 80 listening. Okay, really simple, really easy. We can say NTP should be installed, NTP should be enabled and running. We can say that this file path location should be running. We can say that these users should be specified and running on the box. We can say the user should have these permissions on the box. Okay, there's a whole ton of what server spec can do. If I show you the resource types, and you can go and you can have a little look at it, but you can see that Docker containers should be running. You can see that processes should be running, IP tables should be running. Everything is on there. Okay. Now the nice thing about this supports Windows. There are a lot of functionalities built in that support Windows. For the Windows developers, it has IS websites, it has Windows registry keys, Windows features, and so on and so forth. So this makes life very easy, and this is now why you can see why I like AMIs. Because not only can I test that the AMI is actually functional and working, but I can run smoke tests before I create the AMI that make me realize that this is now fit for production. Okay, and we can... Personally, I do something slightly a little different. I tag it. So the first time I create it, I tag it and I say tag ready for dev. Okay. Once I know that it goes to the dev server and everything is okay, we can change the tag and say ready for staging. And then once I know it's ready for staging, we can change the tag and say ready for production. And only at that point does Terraform actually make that rollout for us. Now it's just creating a new MI right now. Now, I'm just going to go back to Terraform, and I am just going to change this variable to 1.0.1. And if I Terraform plan right now, oh, actually, let me just show you first one thing. If somebody makes a mistake in the variable name, like I'm doing right now, and if we Terraform plan, if I could spell it, then what it's actually going to do is it's going to go off to AWS and try and find the version of the AMI of that specific version. It's going to come back and say, no AMI exists for that version. There we go. Your query returned no results. Please change your search criteria and try again. So we know that we can't actually deploy a version of an application that doesn't exist. So we have a little bit of a failsafe in there. A little bit. Let's go back again. So what it's going to do right now, it's going to make just two changes, nothing else. Okay, the first thing it's going to change is the launch configuration. It's going to delete the old launch configuration and create a new launch configuration in its place. Okay, launch configuration in Amazon is about the characteristics of the machine. Okay, the size of the machine. Okay, the type of the machine, any user data that you push in that needs to happen on application startup, whether the machine is encrypted, etc., etc., etc. Security groups. There's a lot of information that you can push in, a lot. Okay, so launch configurations are usually versioned, and they're applied to a specific auto-scaling group. An auto-scaling group in this case means that Amazon will tell us that 3 instances of a service need to run, so therefore it will always keep 3 versions of the service running. And I will demonstrate that as well in a second. So we're going to apply it, and it's going to roll out. Now, note what is going to happen here. This is why this is a very safe process. This is not going to change any of my live instances. This is an auto-scaling group change only. And all of my application instances are still running as expected. That's a Packer builder. Don't worry about that one. It just spins up an instance to create it, okay? But I still have the 3 original application instances running as expected. Now, how do we roll out this new version of our AMI? One, we can do it manually if we really want to. We can go to the auto-scaling group, okay? And we can, in the auto-scaling group, we can go to the instances tab and we can click on it and we can say action, and we can detach and create a new one in its place, okay? That's error prone, it's manual, nobody likes doing manual things. About 2 years ago, on GitHub, I found a repository called Aws Missing Tools. Okay, this is probably my most famous and widely used tool within my arsenal right now. And it's got a script inside it called Aws HA release. If you give this tool an auto-scaling group name, it will roll across every instance in the auto-scaling group, create a new one in its place, and destroy an old one. Okay, so this is an orchestrated rollout of new instances within all of the auto-scaling group. So I can actually roll out all of my new servers with the new version of the code using this tool, and we can go and do that, hopefully. I just need the auto-scaling group name. Wow, what a name. And we do Aws HA release, and we'll do A. That. Region equals EU West 1, maybe? No. There we go. So it's found a list of instances, and currently it's going to increase it. So by default, it says that 3 instances will run. It will add a new instance into the auto-scaling group, and it will take one of the list out of the old one and rotate them one at a time. Now we can go back to the AWS console, and we can actually see in instances exactly what it's doing. So here's the new one that's been added in its place, and one will disappear in a second. Okay, so this is a very simple orchestrated rollout of exactly what's happening. Now I said at the top of the talk, you don't need to use AMIs for this. Docker containers can work in exactly the same way. As long as you orchestrate the rollout of your Docker containers, don't use Ansible and set it to run across all your servers at the same time so that it kills all of your Docker containers at the same time. You need to do it in a gradual step-by-step way, otherwise you're going to get application failures. If I refresh the instances, we can see that one is going to hopefully disappear in a second. It actually gives you all of the output as well. Come on, machines. Come on. It's thinking about it. It's one of the most difficult parts of an AWS demo like this. The smaller the instance, when you're trying to be a cheapskate, means it takes longer to start up. And I'm using T2 micros, so they take about 60 to 80 seconds. But if we refresh again, we should get a new one in the load balancer, hopefully. Come on. Instances. It's going to add it. There you go. So it's now it's found that it has a desired capacity of 4. So there's 4 instances in the load balancer, and it's telling you I'm going to take this new one out of the load balancer, and then one by one it's going to destroy those new ones. So everything here is like uber simple, like crazy uber simple. And I'm sure if I refresh this, and 1 in every 10 or something like that, there you go, 1.0.0 or 1.0.1 has rolled out, and we can see that it's a gradual release into our infrastructure. Now, the 2 things I've showed you there, firstly, Packer builds. Don't run Packer builds from your local machine. Okay, these can be put in a CI tool. Okay, there are so many CI tools today, right? If you're not using a CI tool, this is a very good place that you can start using one. And all it can do is it can just build images. It can also build your Docker containers if you're using Docker, if you're using containers. Okay, so it's really important that you do that, and it's really important you put that in place. Okay, then you can link builds between saying, hey, this Packer build is finished, therefore link into this Terraform tool with the new version. Because again, you can pass the environment variable in to say the new version, or not the new environment variable, the new CI variable into your script to say the new version of the Terraform tool is available. Anybody got any questions? Anybody care? Question over there, thank you. You got a microphone for? It's coming.
Is it the approach you actually use to upgrade the instances using the scripts, or as far as I know, because I work very a lot with the Terraform, there is another approach. When you have, for example, load balancer, autoscale group, and launch configuration, you just pass the name of the autoscaling group, like name plus the launch configuration, and you update just user data in this launch configuration, and this trigger to upgrade the autoscaling group, and you have wait for ELB capacity. So you don't need to run this tricky script, and you can done an upgrade, restoring new machines using only Terraform functionality. It's also pretty cool. I know this HashiCorp is recommend way.
It's a very good question. Well, the point is that you don't have to use an external script to do this. That you can use, there is a part of the autoscaling group in Terraform called wait for capacity. How do I say this in a nice way? I don't trust that, and I worked on it. I know what the code happens under the hood. Okay, so let me step back. Okay, it's not that I don't trust it at all. Okay, for me, personally speaking, not speaking on behalf of HashiCorp at all. Okay, I never spoke about what I believed and what I didn't about Terraform. Terraform is not an orchestration tool. Terraform was not designed to be an orchestration tool. When you have over 1,000 pull requests where people want to change Terraform for what they need it to do, a lot will get merged, and then looking back on it 6 months later, and we think, Christ, that was the worst idea ever to add something like that. Okay, so it's sometimes open source tools become this one-size-fits-all tool, and that's not always the best thing for it. Okay, Terraform was designed as an infrastructure management tool. It then got added on like 20 other things. So I told you at the top that Terraform has a provider which will help you manage your MySQL databases. You have to give it the root password of your MySQL database. Okay, maybe not always the most sensible thing. So just because the tool can do it, I don't always trust the tool. And I can say that only because of the fact that, as I said, I've worked on it. Now, I'm very much a person of, I use the tool that's good for what it needs to do. So I use Terraform to bring up my infrastructure. Then I use a different tool to orchestrate my infrastructure. Then I use CI in order to actually test my infrastructure and make sure that it works as expected. So I can have 3 tools. Fair enough, I know it's 3 different dependencies and 3 different things within your organization, but I'm happy that those 3 tools are used for exactly what they need to be. Okay, very good question. Do I like using configuration management tools on the instances? The answer for that for me is no. I was a huge Puppet user for many, many, many years when I worked in our Windows environment. Okay, I have seen the damage that I have caused by running Puppet because it runs as administrator, right? And as soon as somebody pushes code, if it's not reviewed correctly or you don't think it acts as expected, then it can have catastrophic changes within your environment. I don't know if anyone saw about a year ago, maybe slightly more, there was a fake question opened on Stack Exchange, which basically says, help, I have run the equivalent of rm minus rf / using Ansible across all of the instances. Okay, you must remember when you use something like a configuration management tool, with great power comes very big responsibility. Okay, really big responsibility. So I like to make sure that my CI tool, I can bake everything in. I can then test it. And once it's ready and tested and the AMI is created, that AMI doesn't change. Okay, I don't know if I was using a configuration management tool, for example, I don't know if my third-party dependency that I have that I'm downloading from source every time, if somebody has reversioned or changed the version of a package. Do you know what I mean? So I'd like to make sure I have everything at build time, And then once it's built, that's it. It never changes, and I am confident that this will work. So like, for example, I put in the talk synopsis, is that if an auto-scaling group, if I lose an instance, this is just, there we go. So by the way, it's finished running the orchestration script. So in a couple of minutes, it's just run across every instance. If I go to Amazon, I refresh, we'll see that we have 3 instances running. Let's pretend that it's 4 o'clock in the morning, okay? And we have an application failure where we've actually lost one of our AWS instances. And we're just going to pretend that it's just disappeared. Actually, you know what? We're not going to do it via the auto-scaling group. We're just going to do it directly in the... Let's pretend that Amazon, something's happened, this box, okay, gone. Application server is gone, okay? If I was using a config management tool, I would be slightly concerned because I would have to make sure that it was a successful Puppet, Chef, or Ansible run before that application is ready for going back in the load balancer. Because it's an AMI and it does nothing in application startup, Amazon will launch the new one, and I'm confident, really confident that everything will work as expected because it's tested, it's built exactly the way it should be. Now, I did this experiment at a startup that I worked in. The startup is now bust, but that's nothing to do with me, I promise you. Every 7 days, we had a process from our CI tool which destroyed every instance in our AWS account one by one. Every single one. There was no such thing as an application server older than 7 days. We also did it with our database servers. We had clusters of Postgres servers, three instances per cluster, and or not Postgres, MySQL, apologies. And we just destroyed every one of them by default. And we had Terraform practice doing a database restore from the latest snapshot in AWS every time. So we practiced every time. And I remember when I started at the company, when pager went off, it was like everyone panicked. It was like, oh my God, what's going on? The world is burning down. How are we going to fix this? And after 6 months, when we put all of these practices and processes in place, we turned off people's pagers unless it was a specific type of incident. And all it did, see, all of this code right here, all of this debug code, was just posted into our Slack channel, an alert Slack channel, so that when the application server, application developers came in the next morning, or the operations people, they could just read through a transcript of what happened from the night before. And at that point, they could actually turn around and go, oh, we lost 2 instances of application server X. And then they can actually go and start looking at the logs or looking in Elasticsearch and try and find out what happened before those died. So it meant that we were starting to be very, very confident that everything would work as expected. Make sense? Now, we have, as you can see, just terminated one instance. And as I said, we're going to pretend it's 4 o'clock in the morning. If I refresh the instance lists, look, a new one has come up in its place. So we can just sleep easily. Really, you don't have to worry. I've worked in companies where people will be paged for the smallest things. Okay, and it got to the point where there was so much noise of paging happening, and people were being woken up so many times a night that people would just turn off pager duty or ops duty. Okay, you should only be using that when there's a real problem in your system. Okay, for losing an instance or losing a single Docker container, you can have fail-safes in place that will allow you to do that. Any other questions? Awesome. Now, there was one other thing. I got like 3 more slides. And then there's a time for another question or two. Oh. Now, Mary Poppendike, who's a very famous Agilista, okay, she's amazing. And she's one of the most fascinating people I've ever listened to. Now, she actually always questioned companies. So Mary's the author of Implementing Lean Software, okay? She's been involved in lean software development since the 60s for a company called 3M. She's changed many companies. Now she's a coach, a coach in all this. She always asked the question at the start of her talk, how long would it take your organization to deploy a change that involved a single line of code, and can you do it on a reliable, repeatable basis? When I joined one of the original companies that I started getting involved in the infrastructure for? The answer to that for application development was 7 weeks. Feels like a long time. I know companies now, different types of software, if they're like working on mainframe or working on mobile or something like that, it can be a lot longer, a lot shorter. When I left the company, it was then 6 minutes. Okay, because you can measure it. It can all be plotted and it can all be measured. There's nothing to say that at the point of which you start making the change until when it finishes, that can't be measured. It's called cycle time. Okay, and you can plot it and you can really use that in order to go to your CTO or your boss and say, hey, look, it takes us 7 weeks right now to make any change in our system. But you can also start to make that same measurement on your infrastructure code, because not enough people measure how long it takes to change infrastructure. Okay. I used this same company that I'm talking about, it used to take them months to change the development environment. And I do mean months. That's a terrible word for me to say with this too. But by putting these practices in place, by adding these automated tools in place, we got that down to like days and hours and so on and so forth, depending on which side of the network stack. We were a PII-based company in America, so you couldn't just make database changes really quick. They had to go through auditing first. Okay, so that took a little longer. But application code, no problem. Application servers, no problem. Everything went through very fast and as expected. Now, where do you start? This is a big bad world of infrastructure management. Okay, start very small. It's the one thing I asked you to do. Okay, the first thing. Don't go straight to your operations guys on Monday morning and say, right, boys or girls, don't go straight to them and say, we have to move to AMIs or we have to move to Docker containers. Okay? You start very small. Start by doing something like, hey, it would be really nice if I could send you pull requests for changes to our auto-scaling group in Amazon or changes to our scale set in Azure. But you can, the most important thing is this, the entire thing to take away from this talk is everything can be improved. It doesn't need to be as rubbish as it used to be. Infrastructure management made developer and QA lives very, very, very difficult. It really made life very difficult. If you work in an organization where you can make changes very easily and that changes are automated and rolled out very fast and are audited, then as developers, you can then start to accelerate away very fast and you can actually do what you're good at and work on the best things that you can. If you want, I'll be around outside at the end if you want to come and tell me I'm wrong. But thank you very much for the talk. And as I said earlier, I'm delighted to be back in Kiev. I have like 2 minutes for questions if anybody has any. I really promise I don't bite. Oh, there's one. There's one.
Thank you for the presentation. I have the next question. I'm not very familiar with Terraform. Could you please name some the most big differences between Ansible and Terraform?
Oh, very good question. Name the differences between configuration management tools and orchestration tools like Chef, Puppet, and Ansible versus Terraform. They are not designed to compete. Okay, they're really not designed to compete. Okay, everything that you can do with Terraform within Amazon, you can do in Ansible as well. Okay, now where Terraform actually does things slightly differently is because it's based on graph theory. Okay, because it builds that graph in advance and it knows the order in which things need to happen. Because of the syntax, it will allow you to roll out the VPC before the subnets. It will allow you to roll out the subnets before the route table. It will allow you to roll out the route table before the instances, and so on and so forth. There is no notion of that within configuration management tools. Okay, so if you want to like deploy an entire environment in one go, just using one simple script and one apply, then you can do that. If you want to use a different tool that will allow you to roll out instances and then ELBs after it in a separate operation, then that is fine as well. Okay, I'm not telling you that you must go and use Terraform, Please don't think that this is a sales talk. It's really not. It's about the process of thinking about how you can apply those scripts to production as fast as possible. Okay.
Thank you. And one more question.
Okay.
As I remember, there is one more tool, Salt. I believe it's still alive. What's your opinion about it?
What's my opinion on Salt? It's very good on food. To be totally honest with you, I've never used that tool. The 3 configuration management tools I've used are Chef, Puppet, and Ansible. I've never tried Salt because I've never been able to get the Salt minions running. Never. Like.
Thank you.
Any more? Oh, there's one more.
Hello, and how about branching? So if you talk about infrastructure as a code, so you have branches and you can just put new version. Yeah,
Very good question. What do we do about branching? Okay, so I'm just going to show you the code again, right? By default, inside Terraform, it takes just the source of the module here, okay? Now, it can also have, do you know what, if I just, you can actually basically say a version as well, or you can actually get it to download from GitHub. So what I'm trying to show you, okay, right now the source is on my local machine. It can be git at github.com/stack72/my module, and then v.o.1 or something like that, okay? And it'll download that version of the module, okay? So that way, again, it's a very good point. Don't just use master for everything, okay? Because it's very dangerous. Very dangerous. But you can actually get versions of your modules that you can download that are pre-tested, pre-baked, that your operations team or your development team have tested that they work as expected, and then that they're rolled out that way. So you can just change the source, download from a different location, which is a release within that location. Okay. Now, there's one more tool that I'll show you before we go. There's a tool called Atlantis. Okay, Atlantis is awesome. It's by Hootsuite, and it's a workflow for collaborating on Terraform. Okay, it's open source again, and there's a short video. But effectively, what you do is you send a pull request to your Terraform repository. Atlantis will lock the repository there and then. It will run a plan. It will give you the output of a plan inside your GitHub comments, and then the administrators or specific people can then say Terraform apply, and Atlantis will roll that production out to production. Okay, so it's a very good way of rolling one piece at a time in order to get it out. I encourage you to go and have a look at this type of thing for orchestration of Terraform or orchestration of infrastructure management. It's well worth it. Any others? Okay, I'm being told off. I talk too much. Thank you.